Check 1, 2, 3. Okay, so our session today is about the concept of rate of reaction. Okay. In this case, the keyword is rate. Please don't use the word speed of reaction because that is non-technical. Reaction doesn't go to a certain distance. Speed is distance over time. Because reactions is not going anywhere, we don't call them speed. Instead, we call them a rate, which implies how something change over time. In this case, later we'll see that something means concentration. But as for now, we just need to know that how fast a reaction happens, we call them rate of reaction. Now, before we go into the rate of reactions, we need to know about the concept of the collision theory. Okay. Collision theory is a theory that says what needs to be happen before a reaction or a chemical change can happen. Okay. Now, the collision theory says that reaction will happen is first, two particles they're going to meet each other. Well, because the meeting is never going to be just simply touching each other, but rather it's going to be a fast reaction here. We usually call them, they're going to collide. That's why we call them collision. Okay. So two particles must collide with each other first. And the second, during their collision, they're going to change their kinetic energy into chemical energy. They're going to stop because of at least their speed is going to go slower, and the kinetic energy is going to change into the chemical energy, which is used primarily to break the old bonds. And they must have their kinetic energy must be higher than the minimum energy required. That we call them here the activation energy. Think of the activation energy like the passing grade of a test. Okay. You're going to study, and that's going to be your kinetic energy. If with the study you get enough energy to answer questions in a test, and that happens to be more than the minimum required to pass, then you graduated. You are going to pass the test. Okay, now this tells us about two aspects that will change the rate of reaction. But for now, let's go back into collision theory. So the collision theory says that first, two particles must meet each other. And the second, when they meet or collide, they must have the kinetic energy higher than or equal to the activation energy. Generally, we call them going to be higher than the minimum energy required. That minimum requirement, we call them activation energy. Okay, now, based on this collision theory, we can then understand the factors that's going to affect the rate of reaction. Now, the first part here is about the meeting or collision of particles. This is going to have a different requirement based on the state of matter. If you're talking about the solid can only meet or collide at the outermost layer. Only the outer layer of solid can take part in chemical reaction. The particles inside the skin, if you say so, can only react if the outer skin has been exposed. So in a solid, it's about the surface area. For the same solid, let's say 1 gram of solid, the more surface area they have means more particles available for reaction per second. Hence, they're going to have higher rate. For the liquid, generally for liquid, we are going to have the particles swimming in water. The more particle per unit area, per unit volume means there will be more possibility for them to meet each other. So we're going to talk about the concentration. The more concentration means there will be more particle per unit volume. It has no use that you have more particles, but the volume is also increasing. It's the concentration that matters, not the actual total particles number. How about the gas here? Well, the gas practically is the same with the liquid. We're going to have the concentration. But in gas, concentration is generally going to be linearly proportional to the pressure. So here, we're going to have the pressure. Why pressure? Well, if we go into the linear gas equations, PV is nRT, and we know that concentration is mole over volume. It's going to be P over RT. For the same temperature, the pressure is going to determine the concentration. That's the first part of the collision theory. Collision theory tells us that particle needs to meet first. The more collisions we have, then the more particle is going to react per second. To solid, we need to increase the surface area because on the surface area, only particles at the surface of solid can react. For liquid, it's a question of how many particles per unit volume, aka concentration. For the gas, it's similar to the solid that we talk about concentration, but we don't usually measure concentration of the gas. Instead, we measure the pressure, which is linearly proportional to concentration for the same temperature. The second part of the collision theory is about the minimum level, kinetic energy versus activation energy. So how can we change the rate of reaction? If we want to increase the rate, we can first increase kinetic energy or decrease activation energy. So assuming that we're talking here about increasing, we need to increase kinetic energy. How? Make them hotter. Increase the temperature. Temperature, physically speaking, is the average kinetic energy of particles. So higher temperature means higher average kinetic energy. Some particles will be higher than average, some particles will be lower. But if in general average is increasing, then there will be more particle that is going to be more energetic than a certain limit. On the second, we can decrease the activation energy. How can we decrease activation energy? This is when the catalyst comes into play. If you're adding a catalyst, we're going to decrease activation energy. If we exclude the catalyst, we are restoring the activation energy into the original values without help of the catalyst. Hence, it's going to be higher. So we have them here. Factors affecting rate, there are 5 in total. 3 of them is going to increase collision, and 2 of them is going to change the ratio between kinetic energy and activation energy. That will be it for the first part. Okay. Thank you very much.